Hey, 30-2s. In this video, what we're going to look at is something known as independent events. Okay, let's just think about that word independent in real life before we talk about mathematics. If I'm independent from, say, my guardians, it means what I do in my life, I don't need to worry about what anyone else has to say, right? I'm on my own, I'm taking care of myself. They have no effect on me, right? Wouldn't that be nice? So independent means me and someone else, we have no effect on each other. It's the same thing in math. Okay, let's go and take a peek at what that means and how it looks in math, I guess. But it means the same thing. So two events are independent of each other if the occurrence of one event does not affect the occurrence of the other. So how we write this is we've got two events, P, A, and B. Okay, it's really easy. They're independent of each other. So we find the probability of the first event happening. And because they're independent, we can just find the probability of the second event happening, and we multiply them together. So remember that word and in mathematics means multiply. Now, the opposite of that is if the first event does affect the second event, then these are called dependent. And how we write that is this. So for dependent events, P, A, and B, it's the probability of the first times the probability of the second, and this straight line here means given such that the first event has already occurred. Okay, now that formula looks a little bit more complicated, doesn't it? But don't worry. Okay, a lot of the times you're not even going to need to use it. Now, you don't have to memorize these. Here is your formula sheet, right, which you should always have in front of you. And if I could scroll down, I would show you that right there is what we just did. So here is independent events right there. And there's your dependent events right there. Okay, so there it is. It's on your formula sheet. You really don't need to memorize it. All right. So this one here, the other way to describe this one for dependent events is that this is the formula. It's known as conditional probability. Okay, and like I said, what it means is it's the event, the probability, the second part here, the probability of B given that event A has already occurred. There's only probably going to be one case where you're going to want to actually write it down, but we'll practice it. Okay, first thing we need to do then is let's start figuring out if things are independent or dependent. Very common diploma question, usually numeric response. So here we go. Picking a 5 from a bag with the digits 0 to 9 written on separate pieces of paper, replacing it, and then picking a 6. Well, this would be independent because of the replacement, because the probabilities would then stay the same. They wouldn't be changed, would they? Independent. 3 students are chosen for an executive council to be president, vice president, secretary, or treasurer. Sally is chosen as president, Dean is vice president, Harvey's treasurer. Well, this would then be dependent because once Sally's president, they can't be vice president or treasurer, right? So the probabilities are changing, right? The probabilities are going to change. What's going to happen each time? Whoever is president then changes who can be vice president. Okay, 5 children are drawing stars to see who has to cut the lawn. Well, okay, I'm not even going to read the rest of it. It's dependent because if the first kid draws the long straw or the short straw, they're immediately cutting the yard, right? So what happens on each draw affects the next draw. Okay, so there's, again, the probabilities would be changed, wouldn't they? So the probabilities would be changed. Okay, what do we got here? Selecting a red marble from one bag and a green marble from a second. Well, what's in one bag has no effect on the other. So it's got to be independent. Okay, this last one here, oh, what? There's no words, there's just numbers. Okay, well, how do I tell if this is independent or dependent? Well, what we're going to do is we're going to do our test for independence. And all the test is this, the formula for independence. Does the left-hand side equal the right-hand side? Well, this one here, it says PA and B is 0.25. On the right-hand side, well, PA times PB, so 0.3 times 0.7. Well, if I multiply those together, I get 0.21. Does the left-hand side equal the right-hand side? Sir, no, sir. Then it's not independent, it is dependent. So that's the test for independence right there. Okay, let's try a few more questions here. If a fair coin is flipped 3 times, determine the probability of the tails appearing all 3 times. Shouldn't be a question mark there. Okay, are these events independent or dependent? Well, I flip the coin, then I flip it again, I flip it again. First flip doesn't affect the second flip or the third flip. This is independent. Okay, let's determine the probability then. What do I want? I want tails and tails and tails. And since it's independent, it's the probability of getting tails multiplied by the probability of getting tails multiplied by the probability of getting tails one more time. And it's a half times a half times a half, which is 1/8. The probability of getting tails 3 times is 1/8. Again, don't round unless you're instructed to. Leave it as a fraction. Try another one. Card is drawn from a standard deck of cards, okay, so 52 cards, and then a second card is drawn after replacing the first. The probability of drawing a red 5 and then a black queen. Okay, well, are these events independent or dependent? Well, since we replaced it, it is independent. Since it's independent, what I can do again is find the probability of the first, find the probability of the second, and simply multiply those things together. Okay, I read 5. That's 2 out of 52, right? Hearts and diamonds. Probability of back queen, 2/52 again. Okay, and then I'm simply going to multiply these together. Oh, geez, I don't know. What's 52 times 52 these days? 2704. And then it would be nice, you should always, again, reduce your fractions, and that's 1/676. Okay, there it is. Okay, so practice writing out your probability statements, because when you get stuck on a question, it can really help you. The other reason why I want you to write out those probability statements is, say I made a mistake here. Say I did this and I wrote like 2/50 times 2/50, but I didn't write my probability statement. Okay, so say this was like that, and I didn't write any of it. Well, you're leaving it up to the person who's marking it to try to assume what you were thinking. I don't know what you were thinking at that point. You're wrong. So I can't give you any part marks, right? So always try to write that probability statement. It can save you if you're trying to figure something out, and it can save you for some part marks if you make a mistake. Just a little hint for when you write your diploma. All right, a couple more. In a particular city, the probability of rain on even any given day is 1/4. Determine the probability it doesn't rain on any given day. Okay, it doesn't rain. Well, what I'm going to do here is probability no rain. Well, what that's going to be is that's the complement. So that's 1 minus the probability that it does rain. So now that's 1 minus 1/4, which is 3/4. So let's not forget about our idea of using the complement. Okay, it comes in handy. 4, determine the probability that it rains 2 days in a row. Well, the probability that we have rain and rain, well, assuming that it's any given day means it's independent. That's the probability of rain times the probability it rains, which is going to be a quarter times a quarter, which is 1 over 16. There it is. Okay, not so bad. Last one. Let's not forget about odds. State the odds against there being rain on any given day. Well, it said it rains one time out of 4. So that means for every one day it does rain, there is 3 days where it doesn't rain. So the odds against there being rain. So odds against there being rain. Well, that would be 3, 2, 1. And again, odds against 2 in favor, or 4. And it doesn't hurt to write that down again. Okay, there it is, my friends. Independent events. Not so bad, hey?